Alright, so let's move on and we'll look at another node available in the particle system called pop attract. And this is what we'll use it for. So it can be used for a bunch of things, but one of the common usages is to generate goals. Okay, so if you want particles to move and form another object, then the pop attract node is really good for that. Okay, so let's get started. So what I'll do is, again, we'll just start from the basics. So I'm going to take a sphere, and for the target object, I'll pick up one of the test geometries that we have. So I'll pick up like the test rubber toy, and I'll just move it up. So let's keep it over there. And I'm going to take a Boolean because it has geometry on the inside. Like if you can see here, the arms are just stuck over there. So what we can do is we can take a Boolean union and just attach it to that. So what it does is it gets rid of the internal surfaces, and we can take a null and I'll call it out attract, and I'll also make a separate copy of this and we'll call this out collide. Okay, because we might use it for collision as well. Okay, and then this is simple. I'll just take a null and I'll call this as out emit. Okay, so let's take a pop network and I'll set this up. Okay, so let's set up our basic emission. We'll say life expectancy is 10 and we'll emit for about 60 frames. So we have this. And the way pop attract works is fairly simple. Okay, so let's do one thing. Let's first take a pop force, and I am going to, let's move it upwards and a little bit of randomization. So we'll have this. Okay, so what the pop attract does, okay, I'll just lower that down to 1. Okay, so, alright, so what the pop attract does is it just attracts it to a point. Okay, so by default, it'll attract it to 1 point. Okay, so the attraction default type is kept to position, which is you can just keep it wherever you want, and then just increase the force. So if you press play, you'll see that it gets attracted to that point, and then it keeps sort of coming and going back and forth. Okay, and what you can also do is you can also do something called reversal distance. So at a certain distance, it will sort of reverse out. See, it will do that. Okay, so you can kind of lower that a little bit. And so if you wanted to sort of form, okay, now the problem is it goes too fast. Okay, it's very difficult to control it. So what you always want to do is you want to take a pop drag after this. So if you take a pop drag, that kind of slows it down enough so that it will form, you know, the exact shape that you want. See, like that's better. And what you can also do is you have the option to randomize this as well. So you can just use Vex expression and you'll have, you get a ready-made randomize option. So you can just randomize this a little bit, and we'll randomize it between, let's say, 0.7 and 1. So you'll get a little bit of, you know, randomization with this. Okay, and you also get something called as peak force distance, which is sort of like how close to the point it can actually get. Now, this won't make a lot of difference right now. Like if I increase it, it sort of, you know, you don't see too much of a difference, but it will make a difference once we get to, you know, setting up a goal for the object. Okay, so this is essentially it. Like you can just attract it to a certain point. But what we want is we want to attract it to a piece of geometry. So what I can do is I can just keep it to points, and we can go to second context geometry, and by default it goes to like average position. So you don't really see much of a difference. Okay, so what I'll do is I'm going to get the reversal distance down to 0 and change the match method from average position to point per particle. Okay, and now if you press play, you'll see that it kind of tries to form that particular shape, okay, which looks nice. So whatever the points are on the geometry, that's where it usually ends up. Now the best way to control this is using that age-based drag that we had made, okay, like in I think lesson 2. Okay, so what I'll do is I'm going to take a wrangle and we're going to control both the drag and the velocity using the age. Okay, so I'm just going to drop this in over here and let's call this normalized age, and we'll just set up the, so we'll do f at new age is equal to fit at age comma 0 comma at life comma 0 comma 1. Okay, and then what I want to do is firstly we'll come into the drag and we'll say use vex expression, and what we want to control is the air resistance. Okay, so we're going to take, so it's called air resist, like if you keep your mouse on it, it says air resist. Okay, so that's the parameter we want. So if I say air resist multiply by equal to, and we'll create a ramp. So we'll do ch ramp and let's call it slow, and we'll use at new age. So it will multiply with whatever is the value over here. Okay, and so what we want to do is, let's say it's okay for the beginning and then it kind of starts to slow down. So what we should get is something, over time, see, it starts to slow down the whole thing. Now another thing we want to do is it's sort of, you can see it going out in bunches. So what's the reason why it's doing that is because it moves based on the point numbers. Okay, so if I look at this and you look at your point numbers, okay, you can't make out anything. But based on where 0 is starting is how the particles are moving. So what you can do is you can take a sort. And let's say if we set the sort to y-axis, then the particles will move according to that. Okay, so now the particles are going to move like this. See, you can see it move vertically. Okay, and what I can do is I can just come back in here and, like, don't keep it flat in the beginning. Have it slow down from the beginning, but there you go. See, so this gives you, or if I start to change the sort value to say z-axis, then, see, it moves like this. Okay, or if you move it to x-axis, then it moves like that. And then once it reaches the end, the particles will loop back again to the beginning. See, so you can see like once it reaches till the end over there, the final set of particles come back here. Okay, so this is the simplest way to control it. Okay, now another thing we can do along with this is I can actually start multiplying the velocity as well. Okay, so I can take another wrangle and we'll call it drag velocity, and I'll just take the same ramp. So I'll just copy this. So we'll do control C, come in here, do at V and multiply by equal to the ramp, and what we want is like it should be full velocity in the beginning. Like this is a good way if you want to really sort of clamp it down. Okay, so and then towards the end, let's say if we do this, so you'll see it sort of starting to slow down. See, so it picks up the shape a lot quicker now. Rather than what we were having, like, let's just do one thing. Okay, let me just duplicate this so we can compare it. Okay, let me just take a transform and I'll move it. I'll just move it out here. And let's merge these two together. Yeah, so if I press play, they both should be the same. But what I can do is, let's say if I come in here and I turn off the drag velocity for one of them, what we'll get is C. Yeah. So this one is far closer to it. See, there you go. So what's happening is, see, this one picks up the shape a lot quicker, like we're there by almost frame 90. and that one is still kind of, moving and shaking and trying to come into place. So controlling velocity is a very good idea. It gives you the result a lot faster. So, okay, so we can get rid of that. And you can also try to control it, in a slightly more fancier way. So I can just have full velocity in the beginning, and then it just kind of shuts down totally. Now here, if you come back to the pop attract, the peak distance sort of makes a difference. So if I increase the peak distance, then it doesn't go fully over there. Like it might keep a slight bit of a distance from it. Like if you look at the position, see, it's not matching the exact position. So this is because of peak distance. So if I come back and I bring this down to say 0.01, and if I press play now, see, now it matches it exactly. So that peak distance is important for how close you want your particles to get to the actual point position. And you can also do like a scatter or something. So if you want to come in here, and if we do a scatter, like that's fine as well. Okay, so we can take maybe like 20,000 points, and so if you press play now, see, it looks a little more interesting. Now, along with this, if we want to do something a little more fancy, we can try to pick up a collider as well. Okay, so we'll take a static object, and I can pick up the out collide, and we can merge these together. Yeah, and let's just hide this. So what you'll get is, see, it will sort of hit it and sort of bounce around and give you a slightly more interesting result. Now, what you can do is, with this, if you want it to slide faster, okay, like if I come in here and I lower the bounce forward, you'll see that it won't move very quickly. See, because it's sort of collecting down there, and then the velocity ends and it never forms the shape. Because you sort of stop the velocity, so it keeps sort of doing that. So what you can do is, we can keep the bounce forward around say 1.4. And what that will do is it sort of helps it slide along faster. So it gets to its final position a lot quicker. See, there you go. You still get one odd random one just moving around for no reason. But yeah. And we can take the bounce to 0. See, so this gives you a much more interesting result. Yeah, there you go. That's nice. Now, one final thing to remember in this is, let's say if I come into pop force and I give it a little bit of, noise. So what happens is, if you give it some noise, and you'll notice that it will keep sort of shaking around. Okay, because what's happening is, this generates a force value, and we are just controlling the velocity. So apparently the force is different from the velocity. Just clamping down the velocity to 0 doesn't affect the force. Okay, so the force, like the noise, keeps sort of affecting it. So what you want to do is, in the drag velocity, you also multiply the same thing with the force. Okay, so just come down here, do add force, and apply the exact same thing to it. So I can just take the same value here, do Control C, and do Control V. Okay, so this will get the same curve will apply to the force, and then what will happen is it will stop doing the shaky thing as well. See, there you go. Of course, we might have to lower the amplitude because that's a little too much. And what you can do is, like, if you wanted to move in faster, like increase the force scale. So you'll get it to go faster. Yeah, there you go. See, so that's a lot better. And then just adjust the curves over here. Like how fast you want the drag to come in, and then how fast you want, the velocity to sort of go to 0. All of those things you can just sort of play around. And this is based on the age of the particle. So our age is currently 10 seconds. So it's happening over 10 seconds. But there you go. See, so that's a lot better. So yeah, so multiplying the force with the age is also important. Okay, like you just need to remember that bit. Okay, yeah, so the reason why, okay, so this is interesting. The reason why we're only getting half of this is because I think we're probably running out of points. Okay, so like we have, how many points do we have here? So we have around 25,000 points, no, 15,000 points. And it's probably, you know, not generating those many. So let's do one thing. Let's make around 10,000 points. And so this should give me, yeah, there you go. See, so that's a lot better. Yeah, so we'll keep the sort to y-axis. I think y is nice. Yeah, and then I can just come in here and take a blast and I can delete that. So yeah, let's just come in here and delete non-selected. Okay, so we get this. And then just to make it look a little fancy, I can give it like a, let's do one thing. Let's take a wrangle and we'll calculate the like the age value is already in there. Like we should have the new age in there. That is good. But let's just calculate the speed as well. So f at speed is equal to length of at v. Okay. Yeah, GTH. Okay. Yeah, and what I can do is I can take a color node and try to apply color based on the speed. So we should have, see this, and then it sort of slows down. Let's increase that and we'll set it to two-tone because I kind of like using two-tone. I'll make it dark and remove the grid. So see, so it'll go to yellow and then we can just spread this out a little bit. Make this slightly yellowish as well. Sorry, orangish. So we get this. Yeah, that's nice. And then I can also try to give it some alpha. So we're not covering shading in this, but the things to remember is that the CD goes into your, you know, your color for the shader, and the alpha goes into your opacity. So, you know, it's fairly simple to set it up. Okay, so we'll just take the alpha and let's set it to the age, or let's try setting it up to speed as well. Okay, so let's do like at speed, see what we get. Okay, we might have to reverse it out. So let's do one thing. Let's do a ramp with this. So let's do ch ramp and call it fade. Yeah. And let's create a ramp. And what we want is maybe something like that. So when it's moving really fast, it's sort of fading out. Like let's keep it semi-transparent anyways. And okay, I think this is the point where it stops, which is fine. And let's do multiply by value. Yeah, so we get like an additional control over the whole thing. Yeah, so that looks nice. And then just for fun, I can take a trail sop because it gives you an interesting result. So we can just take a trail sop. I'll go to about, I think 3 should be good. And then we'll take an add. I'll just connect this and let's do ID and let's do a resample. So the usual steps. Let's do 0.05. You can set it to subdivision curve, so it's a little more smoother. And then we can do a color. And what you can do here is, if you want to keep the existing color and then multiply it with this, we can do a ramp from attribute. I'll do curve view and flip it. And then what I can do is, if you have the lab tools installed, okay, so you can get, the lab tools has a color blend mode. Okay, so you can just take a color blend, and this is my first color and the second one, and we can just set it to multiply. See, so what it's doing is it's keeping the original and then multiplying it with this. So the end curve sort of fades out to black, and then the rest of it sort of looks like this. See, and then it sort of fades out to 0. And then we can merge it with the original set of particles. So this and that. See, so we should get something a little more fancy. Or if you just want to, like, you can do a blend here. So you can just keep it to this as well, which is fine. So yeah, so this is a fairly basic but nice usage of the pop attract node. Okay, now in the next lesson, we'll use the pop attract and the pop interact node to generate like a school of fishes. Okay, so just to give you like another example of what you can do with the pop attract.